Imagine staring up at the clear night sky. You look for that familiar, calming silver orb, the one that has guided sailors and inspired poets for millennia. But tonight, it is just gone, vanished. What if the moon just disappeared? Seriously, what would happen if, in the blink of an eye, our closest celestial neighbor simply ceased to exist? Most people think of the moon as just a pretty decoration for the night. Maybe they know it controls the tides. But the truth is far more dramatic. The moon is not just a satellite. It is Earth's ultimate stabilizer. It is the silent, gravitational anchor that keeps our entire planet from spinning into utter chaos. If the moon vanished, we are not talking about a gradual decline. We are talking about immediate, global, geographical reorganization and a long-term existential threat that would render our current civilization completely untenable. Let us unpack the science of this cosmic catastrophe. Part 1. The immediate cataclysm megatsunamis. The very first consequences would be spectacular and absolutely terrifying, unfolding in the moments after the moon's disappearance. Tides are the most visible demonstration of the moon's power. They result from the differential gravitational pull of the moon and the sun across the Earth. When the moon is present, it heaps water up on the near side and pulls the Earth away from the water on the far side. When the moon instantly disappears, that massive, consistent gravitational force that shapes our oceans is suddenly released. It is like snapping a taut rubber band. The ocean water that was being held in gigantic bulges on opposing sides of the planet would be subject only to the pull of Earth's gravity and the residual, weaker pull of the sun. This immediate gravitational imbalance would cause a colossal, rapid sloshing of the oceans. We are talking about megatsunamis. These would not be your standard earthquake-triggered tsunamis. These would be planetoid tidal bore waves surging across all coastal regions simultaneously. Estimates suggest waves hundreds of feet high, fueled by the instantaneous reorganization of global water masses. Every coastal city on Earth, from Tokyo to New York to London, would be instantly scoured from the map. The sheer energy involved would reshape coastlines, inundating vast swaths of land that are currently considered safe inland territory. And while the water is the most immediate danger, let us also consider the night. Without the moon, the night sky would become intensely dark. Moonlight is crucial for many nocturnal hunters and for maintaining the rhythms of deep ocean ecosystems. But that darkness would be the least of our worries. Part 2. The wobble and the weather weapon. Once the immediate water chaos subsides, we enter the phase of long-term climate destabilization. This is where the moon proves its true value as Earth's primary gyroscope. Our planet spins on an axis that is currently tilted at a comfortable 23.5 degrees relative to its orbital plane around the sun. This tilt is the reason we have stable seasons. This beautiful stability is maintained almost entirely by the massive gravitational counterweight of the moon. Think of Earth as a spinning top. A perfectly spinning top remains upright. However, if you attach a stabilizing counterweight, it maintains that spin angle reliably. The moon is that counterweight. If you remove the moon, Earth's axis of rotation would no longer be held in check. It would begin to wobble erratically and dramatically, a process called axial precession. The tilt could fluctuate wildly over hundreds of thousands of years, swinging from nearly 0 degrees to possibly 80 or 90 degrees. If the tilt approached 0 degrees, we would lose our seasons entirely. The sun would remain perpetually over the equator. Days and nights would be roughly 12 hours everywhere, but the equator would roast under non-stop, intense sunlight while the poles would plunge into permanent, deep freeze. Conversely, if the tilt increased dramatically, say to 60 or 70 degrees, the seasonal cycles would become unbelievably extreme. Imagine a scenario where, during summer, the North Pole faces the sun continuously, resulting in 6 months of scorching daylight. Then 6 months later, it plunges into 6 months of unrelenting darkness and cold. This extreme seasonal variability would shatter global climate patterns. Our current climate zones would cease to exist. Crop failures would be universal because agricultural cycles rely fundamentally on predictable seasons. The resulting climate chaos would trigger mass migrations, famine, and ultimately, the probable collapse of complex human civilization. Part 3. Biological and navigational fallout. The loss of the moon does not just affect physics and weather. It impacts biology at a fundamental level. Many animals rely critically on lunar cycles and lunar light for navigation, breeding, and feeding. Think about marine life. Coral reefs, the rainforests of the sea, often rely on precise timing relative to the full moon to coordinate their mass spawning events. Without this dependable signal, these crucial ecosystems would rapidly lose their ability to reproduce, leading to catastrophic collapse of the oceanic food chain. Then there is the issue of migration. Scientists know that numerous species, from birds to beetles, use moonlight and polarized light patterns generated by the moon as key navigational aids for their long migratory journeys. If that reference point is suddenly gone, these complex navigational systems fail. Imagine millions of animals suddenly lost, unable to find breeding grounds or necessary feeding zones. The resulting disruption would decimate global biodiversity. Mass starvation and ecological instability would ripple through every trophic level. Also, consider the day itself. The moon exerts a tidal braking force on Earth, gradually slowing our planet's rotation over eons. This is why the day is 24 hours now, not 6 hours like it might have been billions of years ago. If the moon vanishes, the subtle drag is gone. While the current 24-hour day would not instantly revert, the long-term trend of slowing down would stop. More importantly, the rotational stability would still be compromised by the wobble. Our rotation might become far faster or slower depending on the chaotic energy involved in the axial destabilization. A slightly faster rotation would mean shorter days and even more violent. Hurricane force winds across the planet due to the increased centrifugal force. Part 4. The geological perspective and the silent aftermath. While the megatsunamis and the climate chaos grab the headlines, the loss of the moon affects even the very crust beneath our feet. Geologically, the moon's gravitational pull contributes to what are known as solid Earth tides. These are minute, periodic deformations of the Earth's solid surface, caused by the same forces that move the oceans. While small, these forces relieve stress in the Earth's crust. Some scientists hypothesize that the regular flexure caused by solid Earth tides might play a minor role in lubricating deep geological processes. Removing this force might slightly, possibly imperceptibly, alter the distribution of stress on fault lines. While it is highly unlikely to trigger massive earthquakes instantly, it represents a permanent change in the tectonic environment of the planet. More poignantly, the night sky itself would change forever. Without the moon to block or absorb micrometeoroids, Earth would be subject to a higher rate of impacts. While the increase would be small, the protective barrier our moon provides against space debris is something we rarely acknowledge. It acts as a shield, bearing the brunt of many impacts that might otherwise strike Earth. The most profound long-term consequence, however, is the permanent loss of predictability. We take the rising and setting of the sun, the cycle of seasons, and the stability of the horizon for granted. These things are hard-coded into our evolutionary makeup, our agriculture, and our technology. Without the moon, Earth becomes an inherently unpredictable world. Survival relies on stability. Stability relies on the moon. What started as a beautiful thought experiment quickly descends into a disaster scenario involving immediate devastation, followed by centuries of escalating ecological and climate collapse. Every surviving human would face a world of unpredictable weather extremes, navigational failures, and fundamentally broken seasons. The very concept of a dependable calendar year would vanish. The moon is not just a light in the dark. It is our planet's vital organ, quietly ensuring the gentle, consistent, and predictable conditions that allowed complex life, and eventually us, to evolve and thrive. So the next time you look up and see that steady, serene disk hanging in the velvet blackness, take a moment to appreciate it. That silent companion is the reason we have the tides, the seasons, and the stability necessary for our civilization to exist. If it were gone, the very physics of Earth would revolt, reshaping geography and silencing life as we know it. It is the anchor that holds our world together, and without it, everything falls apart.